correct? So anything that we understand has to be understood from the real world perspective. So is the collection is the real world? Did you all understand the collection from the real world perspective?
Yes, sir.
Okay, so what is it actually in the real world? So we discussed about many examples in the real world, right?
Yes,
So
sir.
what sort of a collections do we see, Divyashree?
Sir,
What sort of,
like
yeah.
to store and manipulate the group of objects, sir.
No, that is technically, Amma, basically, but in the real world, see, why do we always go back to the real world? So
To
why do we
understand,
always try to go back to the real world?
to understand reality.
Yeah, to understand the application of all the concepts that we discussed in the software world, they apply in the real world only, correct?
Yes, sir.
So if there is a concept that you cannot apply in the real world, then it is useless concept, correct?
Yes, sir.
So do we see the queues everywhere?
Yes, sir.
Physical queues, do we see physical queues everywhere?
Yes, sir.
Okay, hospitals, shopping
sir.
malls,
Yes, sir.
right? Supermarkets, they're all queues, right?
Yes, sir.
So what do we see? The people standing in the queues and purchasing the stuff.
Yeah.
Okay. So now the same queue concept exists in the software collections, right?
Yes,
Okay.
sir.
Okay. So then basically do you see collection of students, collection of professor in the real
Yes,
world?
sir. Yes, sir.
So collection of goods, when you go to a
Correct.
supermart or D-mart, you see collection of uh, goods, right? Electronic shop, you say collection of fans, you see. Do we see collection everywhere?
Yes, sir.
Yes, sir.
So if you go to your wardrobe, do you say collection of dresses, right?
Yes,
Yes,
sir.
sir.
So the basic concept of collection is that whatever is happening in the real world. So what is the difference between real world and the software world?
Software is reflected in real world.
So the software world is nothing but it's an information world,
Yes, sir.
right? The real world is the physical world.
Physical world.
So it's a software world is a representation of the physical world in information form. That's all is the software world, right?
Yes,
So
sir.
you have a group of students, group of professors. They're all the people in the real world. So they are being represented as a collection of students and collection of professors in the
Professors.
information world. So in these collections, we have basically the ordered collections and unordered collections.
Unordered collections.
So what is ordered collections? We have a collection of the information in a consecutive memory locations. They're all called ordered collections, like array list, vector, tag, this thing. What is unordered collections? You have a collection of information that is not in the consecutive, but they're all linked together using a memory location by storing the memory location of the existing value. That is unordered collection, right? So what are the common operations that are required for any collections? What sort of operations are required? So what sort of operations do we need to perform in any collections?
Push operation, pop operation,
Yeah, that is for the stack.
stack.
Stack is last in, first out. You push it
First
on top and then pop it from the top, right? But in
Insertion.
general, what are the common operations we said that are required? You have to add a
Adding,
single element, add
deleting,
multiple
sorting,
element, remove single element, right?
detail all,
Remove multiple elements, contains, check for a search for a single element, search for multiple elements, contains all, conditional
size,
removal, check what is the size of a collection, whether the
clear,
collection is empty or not, right? So these are all the common operations that are applicable for all the collections. So what is the supreme interface for all the collections? What is the supreme interface? We discussed yesterday. I showed the diagram also.
Iterator.
Huh? Divyashri? So what is the supreme interface? It is iterable. So what is the supreme interface? It's called iterable. So what are the methods? What is the purpose of an iterable? Iterable is like a pointer to check whether next element exists. If it exists, get the next element or remove the element. These are the three methods, right? Has, next, and remove.
Next.
So what are these common methods we just discussed? Where all they defined in? Add all. Where all they defined in? They're all defined in collection interface. Where all they're defined in?
Collection interface.
Add all, remove all, remove if, size, empty, clear, right? So these are all the common collection operations that are defined in collection interface. So what are the other three interfaces that inherit from the collection interface? There are three interfaces that extend the collection interface. What are those three?
As next.
No, set, queue.
Set, queue, list.
So these are the three interfaces which extend the collection interface, right? So what is the difference between a interface and class? We discussed that. What's the difference between interface and class?
Interface contains method declarations.
Exactly. And class contains?
Attributes.
No, class contains implementation.
Implementation, yes, sir.
Of these interface methods. Class contains the code implementation of these interface methods, right? So now, what are which all classes implement the list interface? Huh? We discussed in the first day, array list, linked list, vector and stack. They all implement the list interface, right? So which classes implement the queue interface?
Priority queue.
Priority queue and array DQ.
Array DQ.
Okay, so what is a DQ? What is the difference between DQ and DQ?
Double-ended queue, sir.
So double-ended queue is you can add or remove from both ends.
Both ends.
What about the queue?
Queue is a single.
Queue you can add it at the tail and remove it from the head. So you can add it at only one end and remove it from the other end. Whereas the double-ended queue is you can add or both ends and remove it from both ends. So which all classes implement the set interface?
Has set, linked has set, preset.
Exactly. Hash set, linked hash set, and tree set. So what is the unique feature of how do you define a set? What is the difference between set and list?
It will not allow duplicate values in the list.
And which one will allow the duplicate values?
Array list will allow
the duplicate values, but set does not allow the duplicate
values.
So what is the definition of a linked hash set?
maintains the insertion order.
Exactly. Linked hash set maintains the insertion order. Definition of a tree set?
Maintains the sorted order.
Absolutely. Sorted order, right? So whatever is the content, if the content is string, they're all sorted in the alphabetical order. If the content is integers or long, they're all sorted in the numerical order. Right? Okay, so these are all fundamentally are various collections we have discussed, and now I'm going to show you the code of each of these classes, sample code, so that you can actually do the exercises. Right? Okay, let's look at the Okay, let's start with the array list, right? So what are the classes we have to implement all these collections and which package they're all located in? They're all located in java.util
Util dot.
package. Okay. So in that you have to import array list class, collection, that is an interface, iterator class. So these are all the things you have to implement. So what is that we have to do? How do you clear it array list? So they're all you have to declare. This is how you declare the array list. One is the type and this is content. What is that? Content. They are all called generic type. Is diamond bracket, whatever we put, they're all called generic data type. Okay. So we are declaring, how do you declare? You declare array list of string. This is the object type, employee list. You create the array list. So what is the difference between array list and array? We've discussed it. Soumya, what's the difference between array list and array? Kavya, Uday?
Arrays have a fixed size while array list has dynamic, sir.
Exactly. Arrays are fixed size. Array is fixed size. You declare as a 10 element, that is 10 element. You cannot add the 11th element. Whereas array list is dynamic size. The difference between array and array list is array is a fixed size and array list is a dynamic size. That is what you need to remember. So this is the create declaration and initialization of array list, right? Then, so because this is a string, we are adding 3 employees to the employee list. Okay. Then we are printing the employee list. So what are the various methods we discussed in the collection? Size method. So employee list dot size. It gives the size of array list. Second is you want to check whether the array list is empty or not. So what is the method we are using? Is empty. The third is we want to search and see whether particular employee exists. So that is what is employee list dot contains, and you pass the Bob, a string. So then it returns what? What does the contains returns? It returns is it true or false, right? And you want to search for multiple employees. Then what do you have to do? Create
Contain all.
another employee list and add all the employees that I want to search. Then you say contains all. So it checks whether these both all these 2 employees exist in the employee list or not. That's the difference between contains and contains all. Okay, that's another method where you're checking. The second is you want to convert, you can convert the array list to array. So that is what this method is, right? We just discussed about what is the difference between array list and array. Here, you can convert the array list to array by calling the method called to array. So then it gives the array. Then you can print the values of employee. And add all, also we discussed. So now we want to add. So add all means what? You create 2 additional employees. So create the array list of additional employees and add Yvonne Frank to it. And now to existing employee list, add all and pass this additional employees. So now originally how many employees were there? 3. So now we are adding 2. It will become total how many employees? We'll get the 5 employees. So now we want to remove all again. So we are adding these 2 employees and then passing that to remove all. So 5 becomes again 3, right? So then what is retain all? So we discussed about retain all and remove all yesterday. Does anyone remember
Yes,
the
sir.
differences?
Yes, sir.
What is the difference?
Retain all, it will only deletes the element of invoke collection, sir.
Okay. And remove all?
It will remove the all elements from the
All the employees or whatever is the main passed in the parameter. So those are all will be removed from the original list.
original.
Right? So in case of retain all, whatever you passed on will be retained, the rest will be removed.
Deleted.
Right? So retain all and remove all are mutually exclusive relationship. Please remember that. Okay, so that is what is the retain all. Then clear. What does clear do? Removes the, makes the array list as empty. So let's run it and see it. Okay, let's look at the. So let's look at from the top. Right, we created the array list. Now, initial employee list. We have added Elise, Bob, and Charlie. So now this initial employee list printed Elise, Bob, and Charlie. Right. Now the second is number of employees. It printed 3. The third is empty. We were checking is the employee is empty. It returns false. The next checking. Does the Bob exist? Yeah. So because since Bob is there, Ellie is Bob, Charlie. So it returns this contains true. So now next we are saying contains all. What is the contains all we're passing? Elise, David. So does the David exist in this list? It is not, right? So that is why it's returning. Does the list contain all employees? What does it return? It returns false because David is not there, right? So it returns false. Okay. So next is it converting it to array. So convert it to array and printing the array values. So next, what are we doing? Add all. So we added Eva and Frank. So after adding all these additional employees, how many employees we have now? 5. Elise, Bob, Charlie, Eva, and Frank. There are 5 employees. So next, after removing employees in the search list. So what is being removed?
Should remove Eva and Frank, no, sir.
Yeah, that is what I'm just wondering. Okay. Eva, Frank, Elise, Bob, Charlie, Eva, Frank. Okay. After removing all employees in the search list, it should be, that's very interesting. Search list. No, sorry. We're passing search list here. Hold on. What is search list contains? Search list was here. Elise and David. Kavya. So this is the one that we are passing. Search list
So
contains
for
what?
the first time, we have taken employee details, no, sir. Employee details or
See, remove all. What is the parameter we're passing? Search list.
search list.
Not additional employees. We're not passing Eva and Frank. We're not passing. So what is the parameter we're passing?
Search list.
Okay. So what are the values of search list?
Elise and David.
Elise and David. What are the values? Elise and
Elise and
David. So now David is not there. So what is being removed?
Elise.
Elise is removed. So David is not there, right? That is why you have Bob, Charlie, Eva, and Frank. Understood?
Yes, sir.
Yes, sir.
Okay. So that is the reason only Elise is there in the search list. So David is not there. That's why Elise is removed. So now it printed Bob, Charlie, Eva, and Frank. So now retain all. Additional employees what? Eva and Frank.
Frank.
They should be retained. So now Eva, Frank should be retained. So Bob, Charlie should be removed. So that's why.
Removed.
So now after retaining, so what exists? Only Eva and Frank. So the Bob, Charlie is removed. Right now clear. So we're calling clear. After clearing the list, empty employees empty. Understood, everyone?
Yes,
Yes,
sir.
sir.
Okay. So this is how the methods that we discussed in the collection interface, which are being implemented by the array list. Right? So collection is just an interface. Interface means only method declaration. Which is the class, whatever is the class. So you remember this diagram, everyone should remember this diagram. This is very, very important diagram. Right? So in this diagram, what is the blue color represents?
Interface.
Interfaces.
The blue color ones, they're all interfaces. That means they're all method declarations only. What is the green color represents?
Classes.
All classes
Classes.
which implemented these interfaces. Okay. And then what is this implements? If you see the arrow with,
Yes, sir. Under
right?
comes.
These
Yes,
are
sir.
all arrows. What? For example, if you see linked list implements, it implements both list interface as well as DQ interface. Whereas array list, vector and stack, they all implement the list interface. Array DQ implements, DQ extends the queue. So that means DQ contains queue classes
Q.
as well as DQ classes. Similarly, sorted set extends the set. Set is an interface. So that means sorted set contains methods defined in the set as well as additional methods defined in the sorted set. Okay. Hash set and linked hash set, they all implement the set interface. Priority queue implements the queue interface. So this diagram is very important. All of you, please remember it. I'm going to share this PPT also with all of you, right? So please, you need, see, I don't know how many of you are actually doing the practice, writing the code, whatever so far we covered in last 2-3 weeks. How many of you written the programs? All the Java concepts, abstract classes, interfaces. How many of you are practicing it daily?
Our classes have done, sir. From last to like buffered section.
So
I've
can
not
all of
done.
you actually post a message whether you're all practicing it or not in the chat room? Soumya, Nishwita, Tejaswini, Nichanand, Divyasri, Narendra, Sisindra. Can you all post your messages? You're all practicing regularly whatever you have learned in the class or not? Okay, let's see. We're all practicing. Tejaswini said yes. Soumya said yes. Okay, who else? Tulasi said practicing. Nichanand said yes. Uday yes. Divyasri yes. Narendra yes. Nishvita yes. Okay, wonderful. Good to hear that. All right. Okay, so that's about let's go back and look at the next class. So employee management, we have seen how the can be utilized as a employee. These are all actually the real practical applications. Whatever I'm showing it, they are not dummy. So all the employees, they're all uses the employee management uses the array list class. Now let's look at which class is this. Vector, okay. Order processing. Which class are we using this? This is double-ended queue. Okay. Task management. Okay, linked list. So now let's look at the next one, linked list. So what is the thing? Task management. Have you heard of tasks? What is the task management? Definition of a task management?
To check whether the given task is completed or not.
Exactly, right? So basically everything happens as a task only. So basically, let's say you have to write your final exam. So what do you do?
We'll
Study.
prepare, sir.
So preparing for the final exam, is it a single task or multiple tasks? Huh? So you have to prepare for final exams and write it. Is it a
Multitask, sir.
single task or
Multiple tasks.
Multitask, sir. Reading and writing exams.
task,
Multitask.
right? So
Yes,
you have
sir.
to plan for it. So your final exams are 6 subjects. So which subject today, what subject I should read today, next 2 hours, what is that? So you write the list of tasks, right?
Yes, sir.
You have to write it. So is there a dependency of the task? So in your preparation, is there a dependency of the preparation for the final exam?
Yes, sir. We need to check from
Exactly,
the
right? So now let's say if you want
notes.
to study the second chapter, can you directly study the second chapter without studying the first chapter?
No, sir.
No, sir.
So if you study the second chapter without studying the first chapter, you will not understand it, because whatever the concepts required for second chapter are explained in the first chapter. So what do we call that? That is a dependency, right?
Yes,
So
sir.
the linked list is what? How do you define the linked list? Linked list is first task, then connects to the second task connects to the third task. So what does it mean? Third task is, so when will you reach the third task? Whenever you complete the first task
First
and
and
second
second.
task, you can reach the third task. So that is the reason for the task management system on a large projects or real estate companies, buildings. So they want to build it, there are tasks, right? Or in the software projects are also, there is a task management. Employees are there, projects are assigned. In the project, there are tasks. So any time task management system is there. So what is the collection that needs to be used? It's called linked list. Is that clear? So now let's look at the, how do we issue the linked list? Right? Okay, so how do we gain? The declarations remain same. So the linked list of string. So there all we have 3 tasks. The first is complete report, attend meeting, review mail. These are all the 3 different tasks. They're all right. Then print the task list. Again, same method, right? Size, empty, contains all. The same way we are doing it. Convert it to array, add all, remove all, retain all, clear. Okay. It's the same functionality, but only thing the difference here is that we're using the linked list. Okay, so now let's run this. Okay, so we have initially 3 tasks, number of tasks, empty. So these are all the various collection methods we have used. This is using this thing, right? Understood? So what is the purpose of a linked list? How it is used in the real life?
Yes, sir.
Hmm?
Yes, sir.
Okay, let's look at the next collection. What is order processing? That is okay. Inventory management. Vector. What is the difference between a vector and array list?
Vector is synchronized, array list is not synchronized.
Exactly. A vector is a synchronized and array list is not synchronized. So what does it actually mean, Divyasri? So what is the purpose of synchronized and why do we need a synchronized?
Sir, it allows to execute one after the, like, primary to perform the critical tasks, sir.
Exactly. Anytime a resource, critical resource needs to be accessed and updated, they all can be done only in the synchronized. So what are the critical resources like movie tickets, bus tickets, train ticket, your bank accounts? These are all the critical resources which can be updated one at a time. Not multiple people can access and update it. Correct?
Yes, sir.
All right. So again, so we created a vector. So what is in what have you heard of inventory management system term? What is inventory management? Hmm? See, inventory management is any business organization or any manufacturing unit. Let's say if a car is being manufactured, right? What is the raw material car company needs?
Wires,
Tires. It requires tires. It requires engines,
Seats.
engine.
steering wheel,
Seats. Yes,
right?
sir.
So what these are all the raw materials it requires, right?
Yes,
So
sir.
that means it needs to maintain them. So if it runs out of the raw material, what happens? Let's say, so what happens if it runs out of these raw material? The car company.
They need to wait for the materials
Exactly. They need to wait for the raw material before a car can be manufactured.
manufactured.
Right? So inventory management system is all the any large company, whatever is the raw material they need to maintain them. They need to maintain the stock. What is maintain means what? Enough. How many tires are available as of now? How many engines are available? How many steering wheels are available? How many bodies are available? Right? How many gears are available? So that is what is called the inventory management system. So what happens? So this inventory management system is continuously updated whenever the item. So whenever the tires are removed, what should happen? So let's say the Honda has, let's say 2000 tires are available in the warehouse, right? So to manufacture 100, it manufactured 100 cars today. So how many tires it have taken out of this? 400 tires. So it started the day with 2000 tires and it used 400 tires to manufacture 100 cars. So how many tires it left with? 1600.
1600.
Right? So that is the continuous process. The inventory management system, every organization, every manufacturer, they maintain the inventory management system, which is being continuously updated with additions and removals of this raw material. Okay? Right? So that is what is fundamentally is what is an example we use it in the vector. So you have laptops are how many laptops are there? How many printers are there? How many tablets are there? Who uses this? This again is Amazon or Flipkart or Chroma. Does Chroma need to use this? How many of you did the shopping with Chroma? Has any of you stopped with Chroma for buying any of the stuff?
No, sir.
No, sir.
Okay. Chroma, what does Chroma sell? Chroma sell electronic goods, right? They sell
Yes, sir.
laptops, they sell printer, they sell tablets. Again, Chroma also, how many laptops it has in the store before it started the store? How many printers it has, how many tablets it has, right? As it keeps on selling it, the inventory gets reduced. And again, at the end of the day, it goes back and looks at it. If it runs out of laptops, what does it do? It orders new laptops and again adds to the inventory. So that is what is called the inventory management system. So again, in the vector also we have add the elements, right? So then, so So then what does it do? It sell the laptop. 2 laptops are sold. 3 printers are sold. Then tablets are sold. Then what happens? The updated inventory after transactions. Then you print it. Right? So then you check again the print options. Size, empty, contains. These are all contains all. These are all the various methods. Now let's run it. Right? Now if you look at it, so that is what is called the inventory management system. Initial inventory is laptops are 5, printer 8, tablet 10. So then he sold the 2 laptops, 3 printers, 1. After that, what happens? Laptops have come down by 3, right? Printers have come down by 5, tablets are 9, right? So this is what is the how these are all the various again operations that we use the collections to display. This is the vector part. Okay, clear everyone?
Yes, sir.
Okay. So browser history manager. So yesterday when we discussed about the browser history, so what is the data structure we talked about?
Stack.
Stack.
Tag. Okay, so what purposes so we said in the for a browser we need to use tag, Divashree?
To retain to the previous page, sir.
It retains the
Like if we remove the P4, if we want to go back to, sorry, like if we close P4, we'll go back to the P3 page, sir.
see that
Previous
is not
page.
basically what we need to understand is we all use back buttons, right? In the browser we use the browser, correct? So in the browser there is a back button. So now let's
Yes,
go
sir.
back here. Let me just show you. So this is the right. So now what is the back button? This is the back button, right? So which page right now I'm in collections in Java. When I click on this, it went to which page? Between hash map and hash table,
Previous pages.
right? Previous page. Now I click again, back again, priority queue. It went back. When I click again, collections in Java. So how is browser doing this?
It is retaining to the previous page.
So can the browser directly go back to the, how does that mean browser has to remember this, right? Correct?
Yes, sir.
So can the browser go back without remembering it?
No, sir.
No, sir.
It cannot, right? So the browser need to remember it. So for remembering it, what is the data structure browser uses? Stack.
Stack.
So it keeps on, as you keep on browsing it, it keeps on pushing onto the top of stack. As you keep on going back it pops the history from the one by one from the thing. And then that's how it is allowing you to go back. Right? So now if I click on go back, let's look at it when did it stop. So see, so at some point it has to stop because there is no back, right? See, you see here now, back is disabled. That means history is empty, right? So the history is empty. So it cannot go back. So that means what? A stack is empty. The stack is empty. Clear? So as you keep on browsing it, it keeps on pushing on top of the stack one by one. As you keep on going back, it uses the pop to fetch the previous page. Again, pop to fetch the previous page, until the history is empty. Okay, so that is how the browser uses the stack data structure for pushing it and so for getting this thing. Similarly, what is the other application of stack we discussed?
Word or Excel, sir.
Exactly, the Word or Excel. Let's look
Excel.
back at the Word, right? Okay, let's look at. Okay, so now I entered A, B, C, right? So now I see Control Z. What happened? Capital C becomes small c. When I do Control Z again, C is removed, right? I'm undoing it. See, I press the Control Z again. See, C is removed. Clear? So what is undo? How do you undo the Control Z? Control Z is the undo operation. So how is it doing? So that means it has to remember it, right? So Word has to remember all the edit operations done by you in the particular order, correct? So how does it remember these edit operations in a particular order? Word internally uses stack data structure. As you keep on editing it, it keeps on adding the operation that you have done onto the stack. As you keep on pressing undo, it go back to the previous operation, previous operation until you don't have anything this thing. Okay, when I press Ctrl Z, now it doesn't do anything because it's out of all the operations that I have done. So that is what is the purpose of. Okay. See, it is very important. You will remember the data collections only when you understand it from the real world perspective. Correct? If you do not apply the application of these collections in the real world, you will not remember them easily. You will not know the differences between the different collections. Okay. So let's go back and look at this history, browser history manager. So what is the collection we are using? We are using stack.
Stack.
Right? So what is the thing on stack? So we want to navigate to first example, then this, then this, then this. There are 4 pages we are going to navigate to. Right? So then print the browser history. We want to go back to this thing. Right? Now we want to simulate the go back. So let's look at the go back method. So in the go back, what we're saying, if the history.size is greater than 2, then history.pop. Remove the previous page. Right? So then the peak operation, what does it do? Looks at this is the stack operation, peak. Looks at the object at the top of the stack without removing it from the stack.
Stack.
So that is called the peak operation. Right? So then this thing is there. Okay. So what is navigate doing it? Let's look at the. So how is navigate doing? All right. What is navigate doing? It is keep on pushing these pages. Those 4 pages, it's pushing on top of the stack. Right? So that is what is this thing is there. So we are navigating to these 4 pages, then printing the browser history, then we're going back. Right? So now we're printing the history after going back. Okay. So now we want to go forward. What is the go forward is doing? So forward page. So we want to look at the current forward page and print it. Okay. So history page method, it's reading all the items on the stack and printing all those pages. Okay, so let's print this. See, these are all, it's first initially navigated to those 4. Right? So these are all the 4. It navigating to these 4. Right? Then printing the initial browser history, we're printing this 4. Right? Going back, browser history. So what is it going back to? It's going back to products. Right? So the one stack, this thing. After browser history, after going back, okay, then went forward, going back to, so went forward, this thing, and print history. Again, rest are all similarly, your size, empty, contains all, array, add all, and remove all, and retain all. This is clear. These are all the various methods. Okay.
Sir, use method from iterable interface.
Sorry?
Use methods from iterable interface that I didn't understood, sir. Last 87th line.
1 second. 87, huh?
Yes, sir.
Okay. What is iterable interface? We said iterable interface contains has next,
Next, remove.
and remove, right? So now what is iterating is doing it here. If you know, let's look at this. Okay, using iterator, right? You want to understand that.
After clearing, it doesn't show anything, no, sir.
Yeah.
So
So
I'll
after
not.
clearing it is nothing in it, right? So that is why it's not printing anything. See, you're clearing it. That means stack is empty.
Yes, sir.
So when your stack is empty, has next is false. Okay, so that is the reason using, so it's not printing it.
Okay.
Okay. So that's why it is not entering this loop at all, because it is empty. It falls here. As next is, it fails here. Right? Because that is empty. Right? To understand this, okay, we can do, to understand this, we can do it immediately here. If you print this method here, right? So now if we print this using iterator immediately after navigate, right? Now it should print. Okay, so now let's run this. One second. Huh? What is that? Or duplicate. Okay. Okay, now we added this in the top, right? So navigated to, so for this thing. So now we did the iteration, right?
Yes, sir.
So we did this navigation, then immediately we're printing the using iterator immediately after navigate to iterate over the browser list. Now it printed all these 4. Remember, after navigate, it printed because, so now stack is not empty. Correct?
Yes, sir.
So, okay. So that is about the stack. Now let's look at the, which one structure is this? This is the priority queue. Okay, so what is the priority queue? Yesterday we talked about the application of the priority queue. Anyone remember? Any of you remember the priority queues? Hmm? Akash, did you check everyone? What is the convenient time?
Yes, sir. I will check today, sir.
Okay, today please check it up and let us reschedule it. If it is more people are convenient some other time, we can reschedule it. Okay.
Yes, sir. Yes, sir. Definitely.
Okay.
Okay.
Yeah, Kavya. So the priority queue we discussed it yesterday. Remember?
No, sir.
Okay. In the hospital when you have a queues, right?
Okay, DQ. Oh, yes, sir. Yes, sir. Jumping
Not
to
the
the
queue.
if
Also, there is a general queue, but some emergency patient, what happens? Comes.
they will jump from the queue and they'll
So the
go to
jumps the
first.
queue and then the emergency patient is paying. That is what is called the priority. A queue where the priority is given to for emergency patient, right? So what is the another way to understand it? When you are driving on the road, so there is ambulance comes. What happens?
We will give space to the ambulance so that it can go
Exactly.
fast.
Ambulance gets the priority over the all the regular view. That is what is called. Otherwise, people have to drive in the queue, right, on the road.
Yes, sir.
People have to drive in the queue in the road. So when an ambulance comes, ambulance gets the high priority over the queue of the vehicles that are driving on the road. That is what is similar. The concept is priority queue, right? So let's go back and look at this. So you have created a priority queue of patient. What is a patient? Patient is a class. So patient is a class. Patient has a name and priority. So we created the patient object. So then use the compare to look at the priority. So who has get the priority? Using the priority, say which patient get the priority, right? So we are creating a patient John with priority 2 critical, 4 is serious and life threatening. Priority 1 Bob. Okay. So what are the this patient has two. One is a name and priority of the patient.
Patient.
Two. Okay. So one is a high priority, critical. So then we print this thing. So treat patient. What happens to the treat patient? So go back and look at the treat patient. So is empty. Then what does the poll do? Retrieves and removes the head of this queue or returns null if this queue is empty. So treating. So treated patient. Okay. So that is what is the okay. Next, let's see. Look at the. So it is printing the triage queue. Treat the patient, and then it calling the treat patient twice. Then print the queue. Then again size and all other operations. Let's look at the run it. Right. Let's go back and look at it. So what are the patients? John, Ellis, and Bob. So initial triage queue is, so now if you look at it, how is it ordered as? So Bob is
First.
first priority. Then second priority is Alice and 2. This is the queue. So treating, who is being treated? So first Bob is treated. The second is John is treated.
John.
Second priority, right? So that is how the priority queue will, using the priority is being used to address the patients. Okay, so these are all the various. I'm going to share this code again, as usual, Google Drive. Please go through it. And let's start with the online quiz for today. Let me share the link. Okay, that's the online quiz link.
Sir,